Okay, today we are finishing up 5.4b and talking about the other method, the third method that we have of solving systems of linear equations in two variables. This method, this book refers to it as addition. Um, Most oftentimes you'll see it in books. This method is called elimination because you'll see as we work through that we eliminate a variable as we work through the problem. So here are our steps, and you'll see as I number them as I do the examples. But first off, if necessary, you want to rewrite both equations in the form of ax plus by equals c. That's your standard form. Then second, if necessary, you might have to multiply either or both. Okay, so pay attention, that could be just one or two equations by a certain number so that the sum of the coefficients equals 0. And like I said, you'll see as I go through the example. After you do that, then you're going to add the equations, which is why they call it the addition, because we are adding equations together. Then you solve for the remaining variable. And then, just like we did before, you're going to back substitute the variable into either, this time it doesn't matter which equation we put it back into, and then of course we will check the solution. Um, okay, so let's go start by doing this first example. When you look at these, we're going to add the equations, and if I add 4 plus 2, I will not get 0. If I add 5 and negative 3, I will not get 0. So actually, I should have started with the first step. The first step is to rewrite them. They're already ax plus by equals c, both of them. Okay, so they're already in that form. The second step, I'm trying to decide if I need to multiply. And since I can't add and get 0, I do need to multiply. And what you do with your coefficients when you're looking at these numbers, does 2 go into 4? It does. Does 3 go into 5? It does not. So the easiest would be to take this equation and multiply it by 2. Except I'm going to multiply it by negative 2 because when I multiply 2 times negative 2, I get negative 4, and negative 4 plus 4 equals 0. So I'm trying to get it so that when I add the equations, one of those coefficients is 0. So this top one didn't change. It's still 4x plus 5y equals 3. The bottom one, 2 times negative 2 is negative 4x. Negative 3 times negative 2 is negative 6y. And 7 times negative 2 is negative 14. Okay, so that is this part right here was step 2 where I multiplied. Now step 3, this part right here, what we're fixing to do, and the answer that I'm going to get is what I have when I add the two equations together. Okay, 4x and negative 4x are 0, so I don't have to write it. 5y minus 6y is negative y, and 3 minus 14 is negative 11. So that's your step 3. Step 4 is to solve that, so I'm going to solve it. I have to solve for y, so I'm going to divide both sides by negative 1, and I'm going to get that y equals 11. I'm sorry. Hold on one second. This is what happens when y'all aren't here with me. A negative 3 times a negative 2 is a positive 6y. So that means that down here, this part of my equation would be negative 11. So I divide both sides by negative 11. Actually, it's positive 11. So I'm going to divide by positive 11 on both sides. So negative 11 divided by positive 11 is negative 1. A lot of positives and negatives. Let me refresh that again real quick here. Okay, so negative 3 times negative 2 is positive 6. 5 plus 6 is 11. And then that gives me 3 and negative 14 is negative 11. I divide by 11. I'm going to go erase these positive signs because that might confuse some people. So I'm just dividing by 11 each time. Okay? All right, so that is step 4. We have solved Okay, and now it says step 5. I'm going to go over here where I have a little more room. Back substitute. So I'm going to take that y equals -1 and I'm going to put it into an equation. And it does not matter which equation you put it into, but 4x plus 5, I know what y is, equals 3. And according to what we just got, y was -1. So then I'm going to solve that for x. So that gives me 4x minus 5 equals 3. We add 5 to both sides. 4x equals 8. Divide both sides by 4. And I get that x equals 2. Okay, so that's step 5. Step 6 says to check. And I will tell you one thing. It says to check in both equations. You do want to use the original, but I already used that original equation to solve it. So you really only need to go back and check it into the other equation that you haven't used yet. So I'm going to have 2x, nope, I'm actually plugging in, so it's not going to be an x, 2 times a variable minus 3 times a variable equals 7. And it was 2x, and x was equal to 2. It was 3y, and y was equal to -1. So that gives me 4. 2 negatives is plus 3. Does that equal 7? 4 plus 3 does equal 7. So that means that the answer to my problem is x equals 2 and y equals -1. And of course, always written as an ordered pair. Okay, let's do another one. Solve by the addition method. And so we have our first step was to write them in ax plus by equals c form, that standard form. So they're not written like that, so I'm going to do that. I have to take this over there, so my sign will change. I'm adding 4y to both sides. So that's, I'm going to go different color there. That is 3x plus 4y equals 2. And I'm going to bring this 2x over here. So that's going to make that plus, because when you move it to the other side, you change the sign. So that's a positive 2x plus 5y equals -1. So that's the first step, rewriting it. Okay, the second step, we're looking for the variables that add together to give us 0, and none of these do. 2 doesn't go into 3, 4 doesn't go into 5, so it does not matter which one you do. I'm just going to choose the x's. So when they won't go into each other, you just have to multiply by the opposite coefficient. So 3, this equation is going to be multiplied by the 2. So I'm going to multiply it by 2 times 2. And this equation down here is going to be multiplied by 3. Now one of them has to be 3. It doesn't matter which one. I'll go ahead and make that one 3, because they need to have opposite signs when you add them together. So multiplying each thing by 2. So 3 times 2 is 6x. 4 times 2 is 4y. Excuse me. 4 times 2 is 8y. And 2 times 2 is 4. 2 times -3 is -6x. 5 times -3 is minus 15y. And -1 times -3 is 3. So I have multiplied each of those equations. So this right here was step 2. Multiplying your equation by some number so that now I have a variable that's going to be eliminated or fall out. When I add these two together, 8 minus 15 is -7y, and 4 plus 3 is 7. So what this part was, this was the step 3 where I added the two equations together. And step 4 is to solve, so I'm going to divide by -7. And that's going to give me y equals -1 again. Interesting. Okay, so that was step 4. Step 5 says take that and put it into one of the equations. It doesn't matter which one. If I have y and I'm looking for x, I'm going to use that one. You do want to use the original equation. So I'm looking for x. 3x equals 2 minus 4 times whatever I had for y. And y was negative 1. Again, notice I didn't use the rewritten because that will catch any kind of mistakes that you might have made. So 3x equals 2 plus 4, which is 6. Divide both sides by 2, and x equals 3. Why am I dividing by 2? Because I'm giving you the answer before I've done the problem. You're actually supposed to divide by 3, which gives you an answer of 2. Sometimes my brain works faster than my mouth does. Okay, so when I put those two together, oh, actually I got to do step 6. Step 6 is to check, and I'm going to check using the other equation. So when okay, now my airliner's going wacky on me, and he don't want to erase that. So let's go over here. Come on. Okay, I think it's going to work right now. So on to step 6. Step 6, excuse me, says that we check. And remember, we already checked, we already used the first equation, so I'm going to use the second one. And that says 5 times a variable equals negative 1 minus 2 times a variable. So it was 5 times y, and y is negative 1, and it was 2 times x, and x is 2. That gives you negative 5 on this side and negative 5 on that side. And that, of course, checks. So the answer to my problem is 2, negative 1. Okay, hopefully you realize that these equations that we've been working with are all lines. And so basically, there are 3 possibilities when you have 2 lines, each equation representing a line. The 2 lines could intersect, in which case this is what we've dealt with before. And if the 2 lines intersect, we have exactly one solution, and that solution is where they intersect. That's what we worked on at the beginning part of the lesson. You also have a case where the 2 lines might be parallel, and if they're parallel, you have no solution. And then you have the case that one line could be on top of the other line, and that's what we call infinitely many solutions, or the lines coincide. So we're going to look at, again, what that looks like algebraically as opposed to graphically. So it says solve the system. I already have it in my ax plus by form. So the next thing I'm doing is I'm looking to see what I can multiply by. This is a 1 and that's a 3. So I'm going to multiply this one by a negative 3. That's step 2 where we figured out what we have to multiply by. And when I multiply this by negative 3, I'm going to get negative 3x minus 6y equals negative 12. That bottom one I'm not multiplying by anything, so 3x plus 6y equals 13. Okay, and then our step 3 is adding the two equations. So when I add them, that's 0, that's 0, so I have to write a 0 on that side. I carry my equal sign down, and negative 12 plus 13 is 1. And I'm sure you know 0 does not equal 1, and that is a false statement, and just like we've had this before, our answer is no solution. And if you ever get that, and you can also write for me that the lines are parallel, then I'll give you a bonus when you work on your quiz or your test. Okay? Alright, let's go look at the next one. Last example. y equals 4x minus 4, 8x minus 2y equals 8. So I notice this first one is not in that standard form, so I have to move the 4x over. It's positive here, so if I put it on the other side, it's going to be negative, and I want that not in Dutch core. So I'm going to have negative 4x plus y equals negative 4. This one is in the form, so 8x minus 2y equals 8. Okay, step 2 says I need to multiply by something, so I got to figure it out. 4 goes into 8 two times, so I'm going to go ahead and multiply this top equation by 2. And when I do that, negative 4 times 2 is negative 8 um, minus 4y. Wait, I'm multiplying by 2. I was looking at the wrong number. Positive y times negative, no, positive y times 2 is positive 2y. Negative 4 times 2 is negative 8. So that's what I needed to have. Okay, and then I'm just writing the second one down. 8x minus 2y equals 8. So when I combine these, so my third step is again to add these two equations together. And you don't have to write down what these steps are. I'm just trying to help you follow the steps. This hopefully will become very natural to you. Uh, 8x and negative 8x, 2y and negative 2y leaves me with 0. Negative 8 and 8 gives me 0. And we've seen that before, which is a true statement. And this is how we write the answer for a true statement. Yes, it has infinitely many solutions, but those solutions are all ordered pairs x and y such that y equals 4x minus 4. Okay, that's how you write it. Any numbers x and y that make that equation true. Okay, of course you could, it does not matter which equation you use. So I could also say ordered pairs x, y such that 8x minus 2y equals 8. So either one of these is an acceptable answer, and you only have to write the answer like that when you come down to a true statement. So remember, except for the true statements or the false statements, every problem can be checked so you know whether or not you're doing things right or wrong. Please come see me if you have any questions.